Snell's law problems number 5. We have a beam of light striking a slab of crown glass, partially reflected, partially refracted. Find the angle of incidence if the angle of reflection, not refraction, is twice the angle of refraction. Whoa! Okay. Some of you expressed some confusion on some of these problems, and I can see why. This is not necessarily that trivial. So, yeah, let me help you out here. Okay. And so what I'm going to do is draw my big old slab of crown glass. There it is, folks. Crown glass. And n is equal to 1.52. And outside of that is equal to 1 because it's air. And we have a normal. Always got to do the normal. So we have some angle. Oh boy, that's pretty bad. We have an incident ray. We've got angle of incidence. Find that angle of incidence. That's the whole problem here. Just what's that incident angle? It's partially reflected, so there's a reflected beam here. Now, if it's reflected, it obeys the law of reflection, which I didn't do very well here. But in other words, this angle is equal to theta reflected. And that reflected angle is twice the angle of refraction. So that's equal to 2 theta r. What I'm doing is kind of using capital R for reflection, small r for refraction. So we have that theta reflected is equal to the incident angle, and that's twice the angle of refraction. So that's a condition imposed by the problem. Okay. It's going to bend toward the normal down here. Whoop. So we have theta refracted. That's the problem. Find the incident angle. All right. So we'll go ahead and write our basic form. N incident sine of theta incident is equal to n refracted sine of theta refracted. And we know that this incident is 1, the incident index. So 1 sine of theta incident is equal to n2, or n refracted, which is 1.52 sine of theta r. That's what we have so far. And now we have, to figure this out, we have a trig identity. Oh, this is where you didn't know you needed to know this. And normally I'm not expecting you to. I wouldn't give you that on a test unless I gave you the trig identity, namely sine of 2 theta, sine of 2 theta is equal to 2 sine of theta cosine of theta. All right, so that's going to be useful because now we can write that the double angle thing is the refracted angle. So, which is twice the angle of incidence. 2 theta is like the 2 theta refracted. So we can write 2 sine of theta refracted cosine of theta refracted, okay, is equal to sine of 2 theta, which is, well, it's theta incident is twice theta refracted. So that's what this corresponds to now. So basically this is down here because theta incident is twice theta refracted, and so the trig identity gives you the connection between those. So 2 theta refracted cosine of theta refracted is 1.52 sine of theta refracted. Now if you're still following this, we got sine of theta refracted here that cancels out with that one. And so we have that cosine of theta refracted is equal to 1.52 over 2 times 1, which is 0.76. Theta refracted is equal to inverse cosine of 0.76, which is equal to 40.5 degrees. So there's theta refracted. Oh, but that's not what we're looking for. What we're looking for is theta incident. Theta incident is twice theta refracted, which is equal to 2 times 40.5 degrees, which is 81 degrees, the coveted answer. If you didn't get lost in the turmoil there, just go ahead and look at that trig identity again, and I think you'll see how that all comes together. And that's problem number